discovery in Antarctica. Researchers find new life under an ice shelf, and the discovery was an accident.
The peculiarities of the creature amaze the crew. This is not the first time that scientists have conducted an expedition of this kind. From 2008 to 2017, the scientific team embarked on several expeditions to find Antarctic feather stars, also known as Pracasinus cryptic marine animals. These massive creatures, which can reach lengths of 65 to an astounding 65,000 feet, resemble extraterrestrial creatures. This enigmatic species was given the Latin name by experts strawberries, because to their striking resemblance, an amazing assortment of around 20 arms change the color of the alien-looking creature's center body from a purple tone to a deep crimson tone. Although the study does not offer exact dimensions of the species, it does demonstrate its enormous size. Genetic tests and a close inspection of its morphological traits were required for the identification of this new species. The Antarctic strawberry feather star is found between 25 to 3,140 feet deep in the Southern Ocean. It can be seen from photographs that the Antarctic strawberry feather star is divided into two distinct portions. The upper half has fluffy, feathery arms, while the bottom half is striped and harsh. The top component broadens and then narrows to form a circular base, while the bottom piece assumes a triangular shape. This particular texture is said to be the result of several arms gradually separating from one another. Rouse Gregg, Narita Wilson, and Emily McLaughlin are both highly esteemed members of the research team. The West Antarctic forest was located 90 million years ago, just 5,160 miles from the then South Pole, but its climate was surprisingly mild. A number of Antarctic feather star species, including the recently discovered Promac coinus fagaras, were documented by their combined efforts. However, scientists have discovered evidence of a temperate rainforest that flourished in Antarctica around 90 million years ago. What's astonishing about this discovery is that it was found in a sediment core sample that was retrieved in February 2017 from the ocean floor in the Amundsen Sea off the coast of West Antarctica. The sample contained ancient forest soil with an abundance of fossilized plant pollen and spores, and CT scans revealed the dense network of fossilized plant roots. Relatively mild temperatures appear to have been made possible by significantly higher than previously predicted carbon dioxide concentrations due to the lack of a significant Antarctic ice sheet. A core sample of fossilized Cretaceous forest soil was collected using a portable seafloor drill rig operated by the research ship V. Polar Stern in an area with an annual mean temperature of roughly 54 degrees F. Johann Kloos, a geologist at the Alfred Wegener Institute and the lead author of the paper, commented on the sample while performing the first onboard evaluations. They noticed right away that the sediment layer had an unusual coloration that was obviously different from the layers above it. Furthermore, at a depth of 89 to 98 feet below the ocean floor, researchers found fossilized pollen and plant spores in the fine-grained clay and silt of the forest soil layer, some of which were from the first flowering plants ever discovered at such high southern latitudes. Their initial analyses also revealed that they had discovered a layer that had originated on land rather than in the ocean. Another surprise was revealed by X-ray CT scans of the material, which revealed a dense network of roots that were so well preserved that individual cell structures could be seen in accordance with the abundant plant fossils. Around 93 to 83 million years ago, the West Antarctic coast was a marshy area where temperate rainforests flourished. These rainforests were similar to those that exist today, for instance on the South Island of New Zealand, despite the fact that there would have been 4 months of darkness annually due to the South Pole. There were several steps in the analysis, but the most crucial one was determining that the sea level was 560 feet higher than it is today, and that the southern polar region's climate during the mid-Cretaceous period could have reached temperatures as high as 95 degrees Celsius. This new sediment core provided the first opportunity to better understand the Earth's warmest climate in the last 140 million years. Scientists study the current climatic circumstances of the plant's modern-day relatives to gain a better understanding of the climate during this warmest period of the Cretaceous. Next, the soil sample was examined for biological, and researchers have gained deeper insight into the rainfall and air and water temperatures in the ancient West Antarctic rainforest. When these analyses are combined, they provide a first glimpse of the temperate climate that this 90-million-year-old swampy rainforest once flourished in. The scientists found that there was an annual mean air temperature of 54 degrees F, an average summer temperature of 66 degrees F, and water temperatures of 68 degrees F in the rivers and swamps. The climate simulations that the scientists ran suggest that these conditions may have arisen if the Antarctic ice sheet had been much thinner and more vegetated, and if carbon dioxide levels had been higher than formerly thought. These findings demonstrate the importance of polar ice sheets in slowing down global warming and the impact that carbon dioxide has on Earth. Although it is now thought that the Cretaceous period may have had 4 months without light, the high concentration of carbon dioxide kept the weather near the South Pole mild and free of ice masses. Because it is too shallow, Ottawa's renowned Rideau Canal will not be able to be converted into an ice rink this winter. This is a very worrying development. On February 13, 2023, the Antarctic sea ice extent, defined as the region with at least 15% sea ice cover, reached a record low, despite the Antarctic ice sheet facing a comparable but much larger scale difficulty with sea ice creation hundreds of kilometers to the south. Mass has been gradually decreasing. Since 2016, the Antarctic continent, which is surrounded by the Southern Ocean and covered in ice, has seen a rapid decline in its ice extent. If present trends continue, the world's sea level might rise by 11 feet as a result of the West Antarctic ice sheet melting. The Antarctic continent houses 90% of the world's ice. The West Antarctic and East Antarctic ice sheets are both parts of the Antarctic ice sheet. The West Antarctic ice sheet is primarily located below sea level. Sea ice, which is formed from ocean water, expands around the Antarctic during the winter and contracts during the summer. Polar amplification, the phenomenon wherein the increase in high-latitude temperatures exceeds that of the global mean temperature, is a clear indication that the Antarctic is not immune to the effects of climate change. The ice sheet covering land is the product of thousands of years of snow accumulation and compaction. This phenomenon is explained by the ice-albo feedback, which indicates that as the temperature near the surface, the ice melts and contributes to the temperature rise. This is because the fraction of solar energy reflected by a surface, or albo, is lower for the ocean and the ground below than it is for the ice. Over the past 40 years, climate change has decreased the average extent of Arctic sea ice but not Antarctic sea ice. There has been a significant decline in the extent of Antarctic sea ice since 2016, despite the fact that this decline in sea ice cover contributes to global warming but does not raise sea levels because the amount of water displaced by ice during its formation is equal to the amount added to the ocean during its melting. This statistically insignificant difference in Antarctic sea ice extent is due to a combination of factors, including strong internal variability and regional tendencies. The Antarctic ice sheet's mass has been declining since 1990, with the last 10 years seeing the fastest loss. The Intergovernmental Panel on Climate Change found in its 6th assessment report that both the region's temperatures and ice sheet mass will continue to fall. We are unable to make any firm conclusions about how much faith should be placed in these projections, because the observed evolution of Antarctic sea ice is not adequately captured by climate model simulations. Rising the ice sheet's growth is significantly slower than its retreat, so any further melting this century will not be reversible on a human timescale. The West Antarctic ice sheet has been melting gradually for a while, which might mean that an unstable retreat that reinforces itself is about to begin or is already underway. However, there are a lot of unknowns in this process. The mechanism responsible for this erratic retreat is marine ice sheet instability. As the ice sheet bed slopes inward, it disturbs the position of the ice sheet grounding line, which causes the line to recede. This, in turn, causes an influx of ice from the ice sheet to the sea, which causes the ice sheet to thin, and so on. Currently, global warming is projected to reach 37 degrees by the end of the century. If the Earth were to sustain a temperature of 36 to 38 degrees,